So here we are going to learn the memory system performance. Memory system performance means we are calculating the memory access time. That is, performance depends on how fastly the processor can access the memory. So if I wanted to write the formula of memory access time in terms of hit rate and miss rate. So what is hit rate and miss rate? Hit rate means we know we have our processor with us, we have cache, then we have main memory. Now I want to access, let us say, some 2000 data. I want to access from the memory. So total access is 2000. Now from that access, some amount, let us say 500 some data is present in the cache. So the hit rate would be what? Hit rate would be those which is, that is 500 is present in the cache. So the total number of hits would be 500 divided by the total access, that is 2000. This would be the hit rate. Now miss rate is what? 1500 data now is missed, has to be taken from my main memory. So that means miss rate is 1500 divided by 2000. This is how you are going to calculate. You are going to calculate the hit rate and miss rate. So hit rate means the total number of hits divided by the total access, and miss rate means it is the total misses divided by the total access. Now the relation between hit rate and miss rate, you can say, is that hit rate is basically equal to what? 1 minus miss rate. This is the relation you can say between the miss rate and the hit rate. Now AMAT means average memory access time. The average memory access time. If I want to write that equation in terms of miss rate and hit rate, is hit rate into, if it is hit, then where I am accessing from cache, right? So hit rate into time in the cache, plus if it is miss, then I have to access from the memory. So miss rate into T of memory. So this is the formula in which I can calculate the average memory access time using the hit rate and miss rate. That is, in hit rate into T of cache plus miss rate into T of memory is a formula of average memory access time. So that is what the same thing that is given here. What is average memory access time and what is hit rate? Now you have to understand that 1 minus hit rate is what? Miss rate. That means if our hit is 90%, that means miss would be what? 100 minus 90, that is 10%. That is what you have to understand. If our hit is 90%, then our miss is what? Miss would be 10%. That is the relation. Now this is just the summary of what was memory interface. Memory interface is how the CPU is there connected to the memory. That is, in between there were a lot of buses we have discussed. The address, the memory, read data. Right, temporal locality is recently used data is supposed to be used again. Spatial locality means what? In spatial locality, the nearby data, which is nearby data, there is a chance of it also to get accessed. Cache hit means if you found the data in the cache, then it is cache hit. Now cache miss means if you have found, if you are not able to find the data in the cache and you have to go and fetch it from the DRAM, then it is cache miss. Then we have learned memory hierarchy. First we have cache, then DRAM, then virtual memory. Then we talk about average memory access time. Now this was the memory hierarchy, and this is the same equation. How do we calculate the miss rate and hit rate? The number of misses divided by the number of total memory access, the number of hits divided by the number of total memory access. That is 1 minus hit rate, 1 minus miss rate. Now this is question says that a program has 2000 data access. The total access is 2000. 1250 are found in the cache and 750 are not found there. So we have to find the miss rate and hit rate. Miss rate would be that which is not found in the cache divided by the total memory access. So found in the cache is given as 750 are not there in the cache, means 750 are the total misses here, divided by the total access is 2000. So we get 750 divided by 2000 as 0.375. You can calculate the hit rate as 1 minus 0.375, or you can divide it like the total data hit is given to us as 1250, because these are the data that is found in the cache. So you can divide 1250 with this 2000, so you will get the hit rate. Fine. Now, if this is the formula in which average memory access time, not in the terms of hit rate or miss rate, but in this time we are learning the average memory access time formula in terms of the hierarchy. We have 3-level hierarchy and 2-level hierarchy. In 3-level hierarchy, we will include the cache, main memory, and virtual memory. So in that, the equation is T of cache. Either we are taking it from the cache, so the time from cache, plus otherwise miss is happening in cache, so we will do miss rate in cache into, if it is miss in the cache, then you can take either from the main memory, or sometime what happened, the miss can happen in main memory, so we have to take it from where, the virtual memory. Then we will take it from the virtual memory. That is the case. So first T cache plus miss rate of, if there is a miss rate in cache, then we will be taking it from where, the memory, T main memory, plus if there is a miss rate in memory, then where we will take from the virtual memory, that is T of virtual memory. So this is the formula that you are going to learn. This is 3-level hierarchy, but 2-level hierarchy where there is only cache and main memory is involved, then it is T of cache plus miss rate of cache into T of memory. Then we are not having miss rate of main memory because only we are calculating the cache and the main memory here. So this is the 2-level hierarchy's AMAT formula, and this is the 3-level hierarchy's AMAT formula. So T, first we will calculate the time in cache, plus, that means plus means kind of treated like or what happens, there is a miss rate in cache happens. Miss rate in cache happens means from where we will take the data, we will take the data from the main memory, but plus again or you can take, what happen is that there is a miss rate happens in what, main memory, then we will take it from where, from the virtual memory. But in 2-level hierarchy, miss rate in main memory and virtual memory is not there. So if there is cache miss rate of cache into taking the data from the main memory, that is only used here. So here we are given to calculate AMAT using 2-level hierarchy. That is a question. So we have given the 2-level cache and main memory, access time of cache and miss rate of cache. Main memory's access time and the miss rate is 0 because we are using 2-level hierarchy. So the formula is first time to access from cache, that is 1, plus miss rate of cache, that is 10, into what, the accessing from the main memory, that is 100. So 1 plus 10 percentages, so 10 divided by 100 is 1 plus 10, that is 11 cycles. So we get here 11. So it was 10%, that is why I converted the percentage by dividing by 100. Okay, so we get 11 cycles. So that means it has to wait on average, this 11 cycles means what, average memory access time. That means it has to wait 11 cycles to get the data.